Hello, and welcome to Backer Breaks It Down. In this episode, we continue to model with exponential and linear functions. So in our previous episode, we talked about how exponential functions have a percent rate of change, and linear functions have a constant rate of change. Okay, and we looked at some simple modeling examples where we were given those two things and the initial value. So what if we weren't given either of those? So we do have ways of finding that change value and the initial value. So for linear functions, that involves us first calculating the slope between the two given data points, and then we can substitute one of those points and that slope into y equals mx plus b, and we can solve for the initial value, and then we can write our function. With the exponential functions, I first need to calculate the change factor using the formula y2 divided by y1 raised to the power of 1 over x2 minus x1. And then I can pick a point, substitute it into y equals a times b to the x power, solve for a, and write my function. Okay, so in our scenario here, it says the value of a 1-year-old luxury automobile is $50,000. Okay, so that right there is a point, and it's the point 1 comma 50,000. And then it says that 7 years later, it is worth 22,000. So 7 years later, so not year 7, 7 years later would be year 8. It has a value of $22,000. So in part A, it says write a function that represents the value of the car V if it has decreased at a constant rate. So what kind of function are we going to write? That's correct. We're going to write a linear function. So the first thing we have to do is we have to calculate the change value. So we need to use our formula, m is equal to y2 minus y1 over x2 minus x1. And then we can calculate our initial value, okay? And so I did all that, and I ended up with a change value, a slope of negative 4,000, which meant that the initial value of the car would have been 54,000, okay? And so I ended up with the value is equal to 54,000 minus 4,000t. Okay, I'm using the same 2 points in part B to write my exponential function. So after 1 year, the value is 50,000, and after 8 years, it's 22,000. So I'm writing an exponential function in part B, and I know that I'm writing an exponential function because it decreased at a constant percent rate. So the first thing I have to do is I have to calculate my change factor. And then once I've done that, I can pick one of these points, substitute it and my change factor into y equals a times b to the x power, and solve for that initial value. And so that's what I did here. So you'll notice here, I've calculated the value of b, and I got approximately 0.889. Here, I'm making the substitution of the 0.1 comma 50,000 into my exponential function formula. I solved for a, and this is what I got. I just rounded it to like the nearest whole number of 56,243. Okay, and then here's my function. V is equal to 56,243 times 0.889 to the t power. Okay, so when you're not given either the constant rate of change or the percent rate of change, you can find it by using the proper formula. And then once you find that change value, substitute one of the given points and that change value into the proper formula and solve the initial value. And then finally, write your function. And that is how Backer breaks it down.